Good morning. In the last class, in the subject field of fluid mechanics, Newton's law of viscosity was discussed. Shear stress is proportional to velocity gradient. That thing was discussed, and the constant of proportionality is called viscosity. This thing was discussed in the last class. Here, in this video lecture, I want to discuss causes of viscosity. Probably there are two causes of viscosity, major causes. One is intermolecular force of cohesion, and another one is molecular momentum exchange. You know that intermolecular force of cohesion is dominant in case of liquids, and in case of gases, molecular momentum exchange is dominant. Means molecular momentum exchange plays the vital role in case of gases, and intermolecular force of cohesion plays the vital role in case of liquids. Due to change in pressure, there is almost no change in viscosity in case of liquids. Due to change in pressure, there is almost no change in viscosity in case of liquids. And for gases, for change in pressure, there is also almost no change in viscosity except for very high pressure. If the gas is under very high pressure, in that case, there is a change in viscosity for change in pressure for gases. Okay, and for temperature, both are temperature sensitive. Means liquids and gases both are temperature sensitive in respect of viscosity. So I have already said that intermolecular force of cohesion is dominant in case of liquids. So when temperature rises, intermolecular force of cohesion for liquids decreases. You know this thing. Intermolecular force of cohesion decreases due to rise in temperature. And since this plays the vital role for the effect of viscosity in case of liquids, so consequently the viscosity of liquid decreases with rising temperature or with increasing temperature of the liquids. And for gases, molecular momentum exchange plays the vital role, and you know that with rising temperature, molecular momentum exchange increases. Thermal agitation increases. Therefore, molecular momentum exchange also increases. So, due to rise in temperature, viscosity of the gases increases. Okay. Mathematical relations are available for different gases. That thing will be discussed later. But here in this class, only in this video lecture, only the causes of viscosity are discussed. Okay, and one more thing I want to add to this lecture is that one more thing is defined. This term is used, no slip condition. No slip condition. You might have heard this term, no slip condition. When fluid passes, fluid means here both the liquid and gases. Okay. When fluid passes over a solid surface, the layer which is layer of fluid which is adjacent to this solid surface will have zero velocity. This has been found experimentally. This has been found experimentally. Will have zero velocity. Where the layer which is adjacent to the solid surface will have zero velocity. This condition means there is no slip in between the adjacent layer and the solid surface. There is no slip. There is no relative velocity. That means there is no slip. This is why this condition is called no slip condition. But weighting of a solid surface by fluid is not same. Is not due to this effect. Okay, weighting of a surface by fluid is not due to the effect of this one, that is no slip condition. It is due to surface tension. Weighting of a surface results from surface tension. Okay. One example I can give you, that is, mercury. When mercury flows through a tube, mercury does not weight the surface. Suppose mercury is flowing through a glass tube. So you will observe that mercury does not weight the inner surface of the glass tube. But no slip condition is still there. Layer of mercury adjacent to the surface of the glass tube will have zero velocity. So still there is no slip condition is still valid there. But mercury does not weight, it is not weighting the surface of the glass. Weighting property comes from the property of surface tension. Okay. Okay, fine. This was the discussion about causes of viscosity.